My name's Bill Anderson. I'm the CEO of Oculus Labs. Oculus is a technology company that's focused on a new kind of security application. We're specifically focused around an information leakage opportunity that most of the information security industry doesn't address. I have a doctorate in cryptography. I spent my entire career in the marketplace and recognized some time ago that as an industry, although we were doing a good job of encrypting data and VPNing it to move from place to place, and we had good access control to our computer systems, what we didn't do well as an industry was actually protect the contents of the computer screen when it came time for the user to actually look at them. For me to turn around, look at the screen and read it. While I'm reading it, that relatively sensitive information is being broadcast around the office for anyone who happens to be looking over my shoulder to view. The threat model goes beyond just the insiders who may be in the same physical space. There are opportunities for tempest attacks that can pick up the emanations that are coming out of that screen, not just in the classical, well-known radio frequency spectrum, but also the diffuse and reflected optical attacks, where there's some well-known characteristics that have been discussed here, where information that's coming off of the screen can bounce off of another flat surface and be picked up with optic sensors fairly far away. So there's a whole variety of risk models that we need to protect against. Traditionally, the information security industry has not had a solution to this, except for wrapping machines in copper Faraday cages, and that doesn't solve the optical emissions problem. So Oculus has been working on multiple technologies for addressing this problem, and one of the ones I'm going to show you today is called Chameleon. So Chameleon is a very high-end solution targeted at the information security industry. We are taking advantage of some equipment called gaze trackers. They're commercially available off-the-shelf technologies. They've never been applied this way before. We use gaze tracker to collect information about where the user is looking on the screen at any point in time, and then we dynamically render a view of that screen around the user's point of view, replacing most of the true content with false content of our choosing that has no relation to the original content. We do this to take advantage of some not so well-known characteristics of vision and of human cognition to make it possible for the user to have a normal reading experience, but for an adversary, whether it's a local attacker looking over my shoulder or a remote attacker getting a copy of what's coming out of this screen, maybe with a tempest attack, maybe with a hidden camera, they're going to see something that is very confusing, information jumping all around, very much unintelligible. It seems hard to believe, and so we've got this camera running right now so that I can demonstrate it to you myself, and you'll see it with the camera. So come on closer, we'll take a closer look. What we have running here is a computer system. It consists of a normal monitor, so this is just a regular flat screen display, and built into the bottom of the monitor is an unobtrusive gizmo. It's a gaze tracker. It doesn't appear to the user, but there's actually a sensor back there that is looking at the user as he's working and determining precisely where on the screen he's looking at any point in time. The data from the gaze tracker goes out over, in this case, an Ethernet cable or a USB cable to regular XP, Windows, Vista machine as a series of X, Y data points. So no visual information is being captured here. It's just X, Y. And that data goes into the Chameleon application that's written by Oculus Labs. Now, Chameleon you'll see running down here on the taskbar. It's a simple taskbar application. You can run it, you can start it, you can stop it, depending on what your policies may be at the moment. And it's configured to protect the information for one of a set of users who are calibrated for the machine. So I've talked about it enough. What I'm going to do right now is turn it on, and you'll see something funny happen. You'll actually see that the contents of the screen are illegible to you as a viewer. So I'm getting closer to the machine now, and as soon as I get closer, I'm just going to have to slide over to the left a little bit. The machine notices that it has a user close to it. So I'm actively looking at the screen right now. Now this is Microsoft Word. This is actually unadulterated Microsoft Word. We haven't had to modify the application, nor have we modified the actual Word document that we're looking at. What you're seeing is the chameleon effect. Oculus Chameleon is determining where I'm looking at any point in time, is intercepting all of this data that was otherwise destined for the screen, and is replacing it on the fly with false information. But it's false in such a way that it's still completely legible to me. And I'm going to read from this document to prove it to you. It says, an official authorized to do original classification or an individual following rules in a classification guide might legitimately, if confusingly, classify a collection of unclassified facts. Now, I don't expect you to believe me. I could have memorized it, but let me show you where that data actually is. If I were to point here, this point on the screen, there's nothing magic about this pen, it's just a pen. It shows you where I'm looking. I'm looking at the word the right now, and when I look, the word appears. The former decision is original classification. The great majority of classified documents are created by derivative classification. Now I'm going to stop telling you where I'm looking, and I'm going to continue to read. And you'll see that almost immediately it becomes really difficult for you to track me. And that's because we're taking advantage of various characteristics of your eyes and characteristics of my eyes, which are different, such that it's hard for you to track. In addition to, for example, the place where I'm looking at any point in time, there are up to 10 false, what we call false windows, interspersed around the screen that are each appearing to reveal true content, but in fact each is showing you a different layer of false information. And that false information is made to move and behave in a manner that will attract your eye and that will fool you and in fact draw you away from where the user is really looking. Now this is Word. We replace three-letter words with alternate three-letter words. In our version 1.1 release about to come out, we do an even better job. We replace words according to their semantic meaning. So three-letter verbs get replaced with different three-letter verbs, four-letter adjectives with different four-letter adjectives. So the result is, if the user is looking somewhere on the screen, and let's say the text is supposed to read, the dog ran across the road. When the user looks at it, it'll say, the dog ran across the road. When the user looks somewhere else, that space on the screen will change to say something like, the boy had a nice lunch, or the cat jumped up the tree. Something that reads like English, but doesn't have anything to do with the true content, and makes the task for the adversary so much more difficult. Because in viewing this display, you have to try to discover where the user's looking, find sense in it so that you can separate it out from the other content, and yet that other content follows the same semantic rules. And so it's equally plausible in a lot of cases. Difficult to do with text. Let me give you a really concrete example of what we can do when we know more about the content. This is Excel, Microsoft Excel. Again, completely unmodified. The underlying data, the underlying application have not been modified. I'm looking at the screen, and every single number on this display right now is false, except for the one that I'm looking at. The challenge, of course, for the bad guy is determine where the user's looking. Next to impossible to do, because we're replacing all of these numbers with equally plausible false alternatives that in fact even have the same magnitude and formatting, as you can see. So let me show you. I'll prove that this is what I'm saying it is. It says that in 2012, this company's sales revenue will be $80 million. Now I look away, it changes to a different number. I'm looking away now. Now I'm looking back, and it changes back to 80. I look here, this number is supposed to be 500,000. When I look away, it changes to something that is probably close to 500,000. I can't tell you because I'm not looking at it at the moment. I look back, it says 500,000. Now one of the questions you may be asking is, this is horrible, how can you stand to look at the screen? And what we're doing, I want to pull back a little bit. What we're doing is we're taking advantage of some things that, again, are not very well known about the human vision system. A lot of the screen manipulations that we're making here are being done underneath the threshold of consciousness for the active user. Our view of the world is probably not what you think. It's not a high fidelity, continuous, high bandwidth view of what we see. In fact, what we're getting is a series of very strange snapshots. Snapshots that are very visually acute in a narrow, about 2-degree foveal window, and then blur progressively more around that central gaze point. Secondly, we don't see everything all at once. What we do is we sample our environment. I'll take a look there, and then I'll take a look there, and then I'll take a look there. And as my eyes move, perform these motions called saccades, from jump to jump to jump, what happens is that the visual system turns off. You literally, as a user, you literally go blind every time your eyes move. One of the ways you can test this for yourself, so you know I'm not making it up, is go look in the bathroom mirror. Look at one eye, then look at the other eye. What you'll see is that now I'm looking at this eye, and now I'm looking at this eye. But you won't witness your eyes rotate through that path. Well, I assure you, you didn't drop out of existence when this was happening. You were there. What happened is your brain turned off the input from your visual system. Okay, so that and some other properties go into the manipulations that we're doing here in Chameleon. We're sensing at 120 samples per second precisely where the user is looking. And we can anticipate and predict, in fact, when the user is in one of these saccadic motions, and this property of saccadic suppression has taken hold. During those intervals, we manipulate the screen. We do it in a way that is not very noticeable to the user, but as you've seen from the camera shots, highly disruptive to the attacker. We take advantage of some other properties that I don't have time to go into in this recording. So, Chameleon comes in a variety of forms as well, and that's something that I want to stress. Today we support protecting natural office documents, so things like Word, Excel, Outlook. We can protect other applications as well. And in fact, one of the best implementations is if you have a custom application where you're deciding for yourself what gets displayed, there's an SDK form of Chameleon where instead of saying to the operating system, here, write this to the operating system, instead of saying fprintf the following data, you would call the Chameleon application to print. And Chameleon would perform its screen manipulations with input from the gaze tracker to do that. And what will happen is the effect will be even snappier than what you see on the screen today. It's much quicker because we're intercepting the data at an earlier point in its life cycle, and we have better control over what comes out on the screen. The second thing I want to talk about is the actual physical form factor. There are a variety of gaze trackers available in the market. We're showing you this nice big integrated package because it demos well, but this is certainly not the only way that you can use the system. There are other gaze trackers, and I've got one example here. This is a small prototype unit that we're working on. It, as you can see, doesn't have a screen attached to it. This one we can use to retrofit to existing monitors in your organization. And so this one's a little big, but what you would do is you typically plunk it underneath the screen on your existing systems, or if you have a regular display, you can snap it on underneath. Oculus is working with a partner to shrink this down in size. So the next generation we're looking getting to be about 1 inch by 1 inch by about 10 inches long, hardened and powered over USB. So you can take this into the field more easily. It's more robust, weighs less, and it costs less. The final objective that we have with that same partner is, in fact, to integrate that sensor technology right into the bezel of a typical computer monitor. And we've got an example here of a sort of typical deployment. Soldiers go into the field today with these kinds of systems. This is a ruggedized, tempest-protected laptop made by Dell and then remanufactured and secured by our partner Hetra. It's a nice, strong machine. It doesn't radiate in radio frequency spectrum, but it does obviously radiate data that comes out of the monitor. So Hetra and Oculus are working on building a gaze tracker right into this display. This will solve a very real and present risk in the field. A soldier today needs to open up and read his orders on the battlefield, and he does that using one of these machines. Unfortunately, they're not always pristine environments. There could be a guy from the Iraqi Defense Force with him. There could be a translator that we don't know very well. This data is a little bit susceptible. In fact, some would say dangerously susceptible to other people just simply looking over the shoulder, or maybe getting lucky with a telephoto lens from a couple of blocks away, getting a fairly clear view of what's coming out on the display. Instead of that model, with Chameleon built in or bolted onto the system, the same soldier will go out to the field, open up his laptop, read the orders, and he'll be the only one in the room or anywhere around him who can understand what's coming out of the screen at any point in time. And the Excel application really serves to highlight that excellently well. If there's latitudes and longitudes and times and code words, things that we have high context around, the manipulations that we can make to protect them are very effective, as you've seen again in the numbers example. Okay.